My first software engineering role straight out of uni was back in 1999. For those who remember it, I was coding in VB ASP. I often get a lot of sympathy for admitting to that. But I got into PHP development. I also get sympathy for that one, but it was a market step up at the time. In the meanwhile, I was also running events. At the time, I was living in London, and I moved to Melbourne, Australia, back in 2002. Got involved with the community over there, running meetups and conferences, speaking at conferences around the world, and getting to meet what would eventually become, I guess, people who would get the job of developer advocate. But back then, the role really didn't exist. And then around about 2010, I got more into the consulting, contracting side of things, security consulting. So at the time, I was quite happy with my consulting gig, taking a week off here or there to go to a conference. And one of the interesting things I love about developer advocacy is, yes, I represent a company and a brand, and yes, I also represent the community back into that company. But at the heart of it, it's about having a real, genuine, authentic conversation with developers in the community about what problems they're facing. I got to find out how different people got to resolve their issues. It wasn't just about them asking me how to solve a problem. I'd be learning from them as well. And that interaction, I think, is just so powerful. One of the things that they say about developer advocacy is that it kind of sits right on the cusp of the edge of the outline of the business. Again, because we are there to represent and bring awareness of the product to developers and help developers use it more effectively. A big part of it is also working out where they're having issues with that, what kind of additional features they might like, or where something's not quite working for them properly, and we can bring that back into the product team internally. So sitting on that cusp, kind of being the best for both worlds, or best of both worlds, but we're trying to make developers' lives easier as well as help the business that we work for, is really rewarding. So I first thought about becoming a software engineer maybe when I was 6 or 7 or 8. I remember having a fascination with computers, and I attribute that mostly to my dad. He was actually a forensic scientist, but he did a lot of work. He had a little home lab where he had testing machines and stuff. And I remember he had chemical reagent testing machines and all sorts. And I guess the closest thing that I can think of nowadays is like a 3D printer. It's basically moving trays and pipettes that come in and out, and they put things and they test things. Nowadays we have similar kind of technology that produces a very different result, but I was very intrigued in that. So he and I did a lot of more on the techie geeky side of hobbies, I guess it was. And when I moved to the UK, we got a PC, like what you would call an x86 CPU based kind of computer, which is what a lot of the current computers, the architecture is based on. We got one of those. I still remember being hugely impressed that we had a 5 megabyte hard drive. But before that, I was programming on an Amstrad CPC 6128. I don't know if that rings any bells for anybody. But yeah, I was programming in BASIC and a little bit of assembly and just dabbling around. And I just loved the satisfaction of writing code and getting a computer to do ostensibly what you wanted it to do. But yeah, I just loved typing stuff and seeing what I wanted to have come out, whether that was, I was playing early on, so I was just tinkering with so many different things, and just the fact that I could make the computer bend to my will was so satisfying. I think it was just inevitable at that point that I was going to get into computer science of some sort. I'm on the front line, right? I like to get my hands dirty. I like to be out there, viscerally engaged with the community. And but one of the things that I learned early on in my career, probably only about 3 years or so after starting my first job, you can actually do more for a team by doing less. When you feel like you're on your own, just sailing your own little boat, and there's 4 or 5 other boats around you, and you're battling the seas by yourself, it's still hard work. Whereas if there's one or fewer boats, but there's somebody out there calming the seas for you, you can actually get a lot more done. That I reduce the amount of coding that I'm doing, and I do other things for them, even if it's really basic things like going out and buying everybody lunch and bringing it back and making sure everybody has a half-hour or 1 hour break to actually decompress and have a chat about things that aren't work related. Make sure they're fed. In the evenings, making sure that food is ordered for people who are working late, all of those kind of things. It seems counterintuitive, but it was a really big lesson for me. If you want to be a software engineer, I would recommend that it's really important to understand deeper levels of just the web development or the coding side of software engineering, understanding core fundamentals about Data structures used to be really important. Maybe they're less important now. But understanding good software architecture, I think nowadays is actually more important to think about the next person who's going to read your code rather than what the computer does with it. Because computers have got so much power, so much memory now that it's not actually as important. You don't want your software to be too bloated, but you're not really going to create bloated software by making your code more readable. You might add an extra couple of operations into a for loop, but if the next person reads it, can understand what it's doing in a minute instead of 10, then you're actually improving future performance of developers. And you're also making it easier to identify where maybe there's a bit of logic that might not be correct when you've got really complicated nested conditional if statements or switch statements or whatever. It can sometimes be really hard to work out what's the logic flow here. Whereas if you simplify that and make it more readable for a human, it's going to be much easier to identify, oh, this part here doesn't read correctly because you want it to read almost like English. And you're more likely to identify business logic issues, security issues, bugs as you're coding, rather than waiting for somebody to report an issue with your software.